Welcome back to you all. In the previous lectures, we have talked about JK flip-flop and we have seen how we were getting output when the condition 1 1 was given. And in 1 1, we were not getting output in SR flip-flop, that was indeterminate condition. But anyhow, we managed to get output at 1 1 also in the JK flip-flop. But still, there was some problem associated with that. And we were not getting a definite output in GK flip-flop at 1 1 also, because there was a race between 0 and 1, and because of that race around condition, the output was not definite. You may either get 1 or 0 at the end of clock. So we have discussed few possible solution of that race around condition, and one solution was to reduce the time period or to increase the propagation delay, but those two solutions were not that much appropriate or acceptable. So that is why I have told you that in next lecture we talk about another solution, possible solution of the race around condition. Okay, so we'll talk about that solution in today's lecture. For understanding that, have a look at this boy and consider, as of now in the figure, he's juggling 4 balls. But consider the scenario in which he is juggling only 2 balls. Okay, and in one ball we have written 0, and in the other ball I have written 1. Okay, and I have asked him to start the juggling at any particular time and to juggle the balls for 5 seconds. Okay, so what will happen at the end of 5th second? We are not sure when we will ask him to stop. We are not sure in which hand he has got which ball. Agree? So this scenario can be considered analogous to that level triggering. In level triggering, your clock was active for a definite amount of time and 0 and 1 was changing rapidly. Okay, so and that is why at the end of clock we were not sure that our output will be 0 or 1. Okay, now consider the second scenario in which I have told to this guy that just hold the ball in one hand, just have 0, and in the other hand just have 1. Okay, and at the 5th second only you have to juggle the balls. So that 5th second, if he will juggle the balls at the 5th second, then he will be able to juggle only once. Okay, and if he is juggling only once, then the mean arrangement of balls will be reversed only. Like if he has got 1 in right hand and 0 in left hand, so after the juggling, in left hand he will be having 1 and in right hand he will be having 0. Simple. So this is the concept of edge triggering. Okay, so we will be using that edge triggering to avoid this race. Okay, so now let's see how we can do that. Here again I have got the clock, but in this case I am using only edge trigger. Okay, so the rest of the things will be same as I have explained previously. These are the edges I was talking about. Only at the arrival of these edges your output will change. Okay, and otherwise your output won't change. So initial that triangle is representing the movement of clock. Here the triangle is representing the output. So initially if I have assumed my output was 1, so it will remain 1 until the arrival of this edge. See, so your output has remained to 1 until the arrival of this edge. Now as soon as this edge has arrived, what will happen? I have considered JK both are 1 1. Okay, so at 1 1 there should be toggling. Okay, and your output was previously 1, so this should goes to 0, as I have explained to you that if that boy is having 1 in right hand and 0 in left hand, then the arrangement of ball will be reversed. So the output your previous output was 1, so next output will become 0 at the arrival of this edge only. Okay, see, at the level of edge your output has changed from 1 to 0. Now it will remain 0. How long it will remain 0? Until the arrival of next edge. Okay, so this is how during an active clock your output is changing only once. Okay, so this is a, mean, you may consider it as a final solution of that race around condition that was occurring. Okay, so in short, we can say that by using edge triggering we can avoid that race. So here I have got three different representation of the flip-flop, block diagram representation of the flip-flop. Similarly, you can represent all the flip-flops we have studied SRD. Okay, here all you have to show is the in the box you have to show two inputs and two different output, and the different outputs are Q and Q bar, or this bar is floating little at a distance of this Q. That's consider it with Q only. So in the first diagram I have represented level triggering. Okay, in the second diagram it is representing your edge triggering. Okay, this is representing your edge. See, this is representing your edge. Okay, so we'll be using these kind of flip-flops or these block diagram representations only in later courses. Okay, and the last is representing your negative edge triggering. You can observe the bubble, okay, in front of that edge. So if I ask you in which of these three flip-flops you will get a race around condition, so your answer should be in the first one. Okay, because in this we are using level triggering, and in the second and third we have got edge triggering, so there won't be any race around condition. What is the difference between positive edge or negative edge triggering? For understanding that, have a look again on this edge. Okay, so there are two edges, as you can see. They mean this is one edge of this clock and this is the other edge of this clock. Okay, so if I am talking about an edge in which your transition is taking place from 0 to 1, like this edge. Okay, so this edge are considered as positive edge, and the edges in which your transition is taking place from 1 to 0, like this edge. See, here we are coming from 1 to 0, so this edge is considered as your negative edge. Okay, so by using any of these edges you can avoid the race around condition. So next is the various tables of JK flip-flop. The first is representing your characteristic table. The next is your truth table, and the last is your excitation table. If you observe them, in this case you can see in the truth table of this JK flip-flop there is no don't care. Okay, and for each input combination you are getting a definite output. Similarly, in the characteristic table also at 1 1 I have written toggling phenomena. Okay, so in the case of SR there was indeterminate case, but now we are my output is getting toggled. By toggling, what I mean, that output will changed from 0 to 1, or 1 to 0. Okay, so this toggle that please mind that the race what we have discussed, race around condition was not desirable, and that was occurring in the case when we are using level triggering. But this toggling is desirable, and we can design some important kind of system by using this toggling phenomena, and that can be achieved in the case of edge triggering. Okay, when we are using JK flip-flop with edge triggering. Okay, so whenever we'll talk about JK flip-flop, in general we'll talk about edge triggered JK flip-flop. Okay, so um, this is all for the day. Similarly, if I ask you to find the characteristic equation of the JK flip-flop, then you have to go with the truth table and you have to solve this for Qt plus 1, considering Qt, JK as input variables, and you will get that as I have explained earlier in the case of SR flip-flop. Okay, in the next lecture we'll talk about conversion of flip-flops. Okay, that's all for the day. Thank you.